Why do different operating systems boot differently? Have you ever wondered why your computer boots up in a certain way? The boot process is the series of steps a computer follows to start up and load an operating system. While all operating systems share some common stages, the methods and components involved can vary widely. This is largely due to differences in operating system design, hardware compatibility, and the specific needs of users. When you power on your computer, the firmware, which can be either basic input-output system or unified extensible firmware interface, kicks things off. It initializes hardware components and performs a power-on self-test to check if essential devices are functioning properly. After that, the firmware looks for a bootable device, like a hard drive or USB stick, based on a predetermined order. It reads a special area on the boot device, such as the master boot record or GID partition table, to find and launch a bootloader program. The bootloader is a small program that plays a critical role in loading the operating system kernel into memory and starting its execution. Different operating systems use different bootloaders tailored to their architecture and features. For instance, Windows typically relies on the Windows Boot Manager, while many Linux distributions utilize the Grand Unified Bootloader. These bootloaders can offer various user interfaces and support 4 multiple operating systems, allowing 4 dual boot setups. The differences in boot processes arise from the unique structures of each operating system's kernel, hardware abstraction layers, and system initialization routines. Some operating systems use Systemed as an initialization system to start user space services, while others may have different processes. The boot process is also influenced by the target environment. For example, embedded systems, desktops, servers, and mobile devices may have specialized boot sequences optimized for speed, security, or hardware constraints. In practical terms, these differences mean that customizing or troubleshooting boot issues can vary significantly from one operating system to another. Users can adjust the boot order and bootloader options through the firmware settings or operating system-specific tools. Understanding these distinctions is helpful for managing multi-boot setups, recovering systems, or optimizing startup times. Ultimately, the reason different operating systems boot differently comes down to variations in firmware interaction, bootloader design, kernel loading methods, and system initialization tailored to their specific architecture and use cases. This variety allows each operating system to manage hardware resources effectively and provide the functionality that users expect.